All right, section 4 starts talking about graphing inequalities. And graphing inequalities is very similar to graphing equations, except instead of having a value, you have a range of values that your variables can take. Another difference is that instead of having just a line, it's going to be either a shaded line or a dashed line with a shaded region to represent all the values that your variables can take. So when you graph greater than or equal to, less than or equal to, your line is going to be solid. When you're graphing less than or greater than, your line is going to be dashed. Okay, it's sort of like the difference between when you're talking about intervals using brackets to include the end values or parentheses because it's an open interval. Okay, so this just tells you whether or not it's an open or closed line. So let's look at an example. We want to graph 3x plus 2y greater than or equal to 6. Now, the idea is to make it look as though it is in slope-intercept form. We want y either greater than or equal to, less than or equal to, whatever it is, mx plus b. Then we have an intercept we can start with and our slope. So that means we're going to isolate this y. So we're going to start by subtracting 3x from both sides. So we'll have 2y greater than or equal to negative 3x plus 6. Then we want to divide both sides by 2, everything by 2 as a matter of fact. So now we have y is greater than or equal to negative 3 halves x plus 3. Now, what that tells us is our slope is negative 3 over 2, and our y-intercept is going to be 3. So when we go to graph this, just like with a line, you always start with the y-intercept. So that's the point where the line crosses the y-axis. It is 3. From there, we use our slope to determine where the next point or points are going to be. So we have negative 3, which means from here we go down 3, and then positive 2, so we go over 2. Down 3, over 2. And you can keep going, infinitely since it's a line. It doesn't matter. Okay, so now I want you to notice that we have a greater than or equal to. Greater than or equal to means we connect the points using a solid line. So we're going to connect all these points using a solid line. We are almost finished. The last point about inequalities is that we need to shade a region where the values occur, because y can be anything bigger than this. Any number, which means there's infinitely many numbers that y can be, as long as it's greater than this. So since y is greater than, what we want to do is shade all of the values that are above the line. So you would just shade this region. And that's what your graph would look like. Look at one more example. Alright, the next example is going to say graph 3x minus 4y greater than 0. Alright, so the idea again is to get it in slope-intercept form, or something that looks like it, which means we're going to isolate this y here. So I'm going to start by subtracting 3x from all sides. So I have negative 4y greater than negative 3x. Then I'm going to divide everything by negative 4. Now, don't forget, with inequalities, when you divide or multiply by a negative number, your sign switches direction. So we go from greater than to less than positive 3 over 4x. All right. Now, what that means is our slope is going to be 3/4. And our y-intercept is actually 0 because there is no constant hanging off the end there. So when we go to graph it, we start at our y-intercept, which in this case is 0. From there, our slope says we go up 3 over 4. So we're going to go up to 3 over 4. You can go up 3 more if you want, and over 4 more. It keeps going. Now, because we're looking at a less than sign, we're going to use a dashed line. Okay, that sort of indicates that it's an open interval. And because y is less than this expression, you're going to shade below. So that would be the graph of this function. Okay, if you have any questions, we will talk about them next week. Otherwise, it's very similar to graphing equations. Take a look through some of the other examples in the textbook. Hopefully this gives you a little bit of insight.